Gravity is a fundamental force that governs the motion of everything in the universe. It's what keeps our feet on the ground, what holds the planets in orbit around the sun, and what shapes the very structure of galaxies. In space, where there are no solid surfaces to stand on, gravity takes on an even more fascinating and crucial role. Let's explore how gravity works in space and why it's so important. 1. Gravity, the invisible force. Gravity is an attractive force that pulls objects toward each other. The strength of this force depends on two things: the mass of the objects and the distance between them. The more massive an object is and the closer it is to another object, the stronger the gravitational pull between them. In space, gravity is what keeps planets in their orbits and governs the motion of stars and galaxies. Can you imagine how different the universe would be without gravity? 2. Orbits, the balance of forces. In space, objects are constantly in motion, and gravity plays a crucial role in keeping them on their paths. For example, the Earth orbits the Sun because the gravitational pull of the Sun keeps Earth from flying off into space. At the same time, Earth's forward motion prevents it from being pulled directly into the Sun. This delicate balance between the gravitational pull and the inertia of objects results in stable orbits, whether it's a planet orbiting a star or a moon orbiting a planet. Have you ever wondered what would happen if this balance were disrupted? 3. Microgravity, the illusion of weightlessness. Astronauts aboard the International Space Station experience what's called microgravity, often referred to as weightlessness. However, this doesn't mean there's no gravity in space. The astronauts are actually in free fall, constantly falling toward Earth, but moving forward fast enough that they keep missing it. This creates the sensation of floating. Microgravity allows scientists to conduct experiments that wouldn't be possible on Earth, such as studying how fluids behave or how the human body changes without the constant pull of gravity. How do you think your body would feel in microgravity? 4. Tidal forces, gravity's stretching effect. Gravity doesn't just pull, it can also stretch. Tidal forces occur when the gravitational pull on one side of an object is stronger than on the other side. This is what causes tides on Earth, as the moon's gravity pulls more strongly on the side of Earth closest to it. In space, tidal forces can have dramatic effects. For example, they can stretch and even tear apart celestial objects that venture too close to a planet or star, a phenomenon known as spaghettification. What do you think it would be like to witness tidal forces at work in space? 5. Black holes, gravity at its most extreme. Black holes are regions in space where gravity is so strong that not even light can escape. They form when massive stars collapse under their own gravity at the end of their life cycles. The gravitational pull of a black hole is so intense that it warps the very fabric of space and time around it. This makes black holes some of the most mysterious and fascinating objects in the universe. Scientists are still working to understand what happens inside a black hole. Have you ever imagined what it would be like to explore the edge of a black hole? 6. Gravitational waves, ripples in spacetime. In 2015, scientists made a groundbreaking discovery: the detection of gravitational waves. These are ripples in the fabric of spacetime caused by some of the most violent events in the universe, such as the collision of black holes. Gravitational waves confirm a key prediction of Einstein's theory of general relativity and offer a new way to observe the universe. They carry information about their cataclysmic origins and about the nature of gravity itself. How do you think our understanding of the universe will change as we continue to study gravitational waves? 7. The role of gravity in space exploration. Gravity also plays a crucial role in space exploration. Space agencies use gravity assists or slingshots to accelerate spacecraft as they travel through the solar system. By passing close to a planet or moon, a spacecraft can gain speed from the planet's gravity, allowing it to reach distant destinations with less fuel. This technique has been used in many missions, including the Voyager probes, which have traveled farther than any human-made objects. What do you think the future holds for space exploration with the help of gravity? Gravity is more than just a force. It's a fundamental aspect of the universe that shapes everything from the smallest particles to the largest galaxies. In space, gravity's influence is profound, guiding the motion of celestial bodies, creating the conditions for life, and driving the exploration of the cosmos. If you enjoyed learning about the role of gravity in space, be sure to like this video, subscribe to our channel,